So a couple sections ago, we looked kind of at graphing polynomials as well as at end behaviors. And this section and kind of throughout the rest of the chapter, we're going to look at solving polynomials. And this kind of relates to what we did in chapter 4, where we graphed quadratics and then spent the rest of the chapter solving quadratics. So looking for x-intercepts. So we're going to look at a few different ways that we can factor or solve polynomials. And when we do that, what we're really doing is a couple different things. Suppose that this is y equals, right? So this is some cubic equation that goes down to the left, up to the right based on its end behaviors, and goes through here. And factoring is going to be our way of finding those x-intercepts, those points of interest. Okay, so when we're factoring, that's really just part of the process of finding those zeros, or it's one way that we could solve an equation when it's equal to 0, which is still just the same as finding the zeros of the graph. Okay, but we're just going to look at it as expressions. Can we get it factored? Because once we have something factored, right? Once we had something factored, it didn't take too much effort to say what the zeros were based on the factors. So getting to the factors is the tough part. This first part, and the thing that you should always look for first when you're solving a polynomial or trying to factor a polynomial, is can you take out a greatest common factor? So a GCF, greatest common factor. So is there anything that's in each of the terms that we can pull out in front to simplify things and make life a little bit easier? So here we have x cubed minus 4x squared minus 12x. There's an x in each term that we can pull out in front. So we factor out an x. We essentially divide an x out of each term. So if we were to divide out an x from everything, we pull an x out of x cubed, well, that leaves us just with x squared. If we take an x out of a negative 4x squared, well, then we just have negative 4x. And if we take an x out of minus 12x, well, that's just minus 12. So we've factored out a greatest common factor, and that leaves us with something that we might be able to factor a little bit easier. So if we have x squared minus 4x minus 12, can we find two things that multiply to a negative 12 and add to a negative 4? Since we're multiplying to a negative, we remember that one of those things has to be positive, one is negative. And this ends up being x plus 2 and x minus 6. So hopefully in chapter 4 you took factoring seriously, because we're still going to be using it. Okay. And again, just for the sake of understanding all the connections of things, if this was equal to 0, if this was an equation we were trying to solve, our zeros would be, from this one, x equals 0, x equals a negative 2, or x equals 6. So remembering the difference between factors, right? Each of those things over here on the left is a factor. And then zeros, right? 6, negative 2, and 0 are zeros of that equation. X plus 2, and x minus 6 are factors. Those are going to be words that we'll use quite a bit. Moving on to that next example, 5x to the 5th minus 80x cubed. Well, it's easy to see that we have an x cubed in each of those terms that we would be able to factor out. But in our constants, what's the greatest common factor of 5 and 80? Well, we could also take out a 5. So if we divide 5x cubed out of each of those, we take out the 5, we take out x cubed. That leaves us just with x, not cubed, squared in the first term. And then 80 divided by 5 is 16. And if we pull out x cubed, well, that leaves us with nothing else, right? So we have 5x cubed times x squared minus 16. Does x squared minus 16 factor? Well, that's one of our special patterns. That's a difference of squares, so that factors into x minus 4, x plus 4. So again, any of the other examples that we do after this, looking for a greatest common factor should always be the first thing that you do throughout this entire section. Always look for a greatest common factor first.